each and everyone. Thanks, Roberto, for the preview or the spoiler, whatever word you prefer. Now you cannot say that you didn't understand the context and the framework behind the project. So, when you see this image, what does it evoke? I mean, I'd say Europe, accessibility, interconnection, and so on. Why I am showing you this picture? Because, as Roberto said, since actually forever, maybe we're talking about the 70s of the previous century, we have been using the standard called GTFS and the Gtfs-Rtto, which has been developed by Google, and it has become the de facto standard. It was the only one existing. People used it, and for people, I mean local public transport authorities. However, in 2017, and then in 2024, the European Union asked to develop something which was more, let's say, European. They asked to create the national access point, on which we had to insert the mobility data with our framework, with our context, which was the Netex and Siri, the Italian profile or whatever profile. So you have national access points, which are each from every country, and then every country is going to insert this data. Then for every country, there are also every region, or however they are called, in which they have their still data inserted. So OTP Italy stems exactly from this need to enable the transition from the de facto, GTFS and Gtfs-Rtto, to the new de jure standard, which is Netex and Siri. By doing so, we can facilitate the access and the sharing of mobility data through these national access points. Just to give you a quick project overview, the project OTP Italy began in 2025 with a focus on three main areas. First, the local public transport data enrichment. Why enrichment? Because, as Roberto said, the GTFS is simple. It provides, let's say, the minimum information for the overall system to work. But Netex and Siri can give way more information, so we can work on that. However, we cannot start from scratch. Most local public transport companies don't want to build a Netex and Siri from zero. So we have GTFS and Gtfs-Rtto, we can convert them. So that's why we're working on a converter. But we are also working on Inopentripplanner. Why? Because when you have the data, you can insert them within the national access point, but it will be just a bureaucratic exercise. You say, okay, I have the data and so on. But we want to give value to the people. This data, as has been said before, can be used by user, and we can enhance their travel experience. So in addition to do so, we are also going to develop a specific graphical user interface for end users, which can contain all the extra data we have added into the project. And we're going to test these on 3 different territories with the data provided by Open Data Hub on the province of Alto Adige, on Trentino, and in Sardinia. This is the overall architecture of the solution. As you can see, we start from the data, from the de facto standard. We enrich them before their conversion through different and multiple data sources. We convert them through the use of a converter, from GTFS to Netex and from Gtfs-Rtto to Siri, both Italian profiles. Then these data converted are then used to feed the routing engine, which is Inopentripplanner, and the results are visualized by end users on the dedicated graphical user interface. How are we working? So first, we had to do a preliminary analysis of the standards. Imagine on your left hand, you have the new standard, Netex and Siri. Okay, but what's inside them? From what do we start? Okay, we have Gtfs-Rtto, we have GTFS, and we have other standards. We had to do a mapping, an analysis of the macro categories of the information expressed by both standards, and define the correspondence. What's in GTFS, that's in Netex. What there is in Gtfs-Rtto, that's in Siri. After doing so, we can understand what's missing in one standard that we can insert into the other. On our right hand, we have GTFS. We merge them, we understand what's missing, what can be done more. What can be done more? This is the data enrichment part. We are working on the alignment of the vehicle routes with the road network, thanks to via map matching tools, and we are going to go more in details on each of these topics. A new logical structure of the different stops by using the definition of stop place and quays, an improvement in the fare management system, and the introduction of infrastructure data in order to increase the accessibility for end users. When speaking about map matching tools, it happens that there are GPS on vehicles that can define the position of the different vehicles. However, they have a not so good precision, as it takes 4 meters from each of the vehicles. This is what you can see on a usual application that defines the route of the vehicle. You see they are just point connecting one from the other, but they don't match with the exact road. This is what happens when you insert map matching tools. Now you have a more detailed information, which also for real-time data defines the exact time of arrival. When dealing with stop, place, and quay, you can see what happens. This is a classic rail station, which is the stop place, and you have the different platforms, which can be called quay. Quay is platform 1, there is quay platform 2, and platform 3. What happens now is that the information is redundant. You see station, 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 platform, platform, platform. When you reorganize the logical infrastructure, you have that the station is the stop place, which contains all the other quays, which are the different platforms. The fare management system is another important part on which we are working, as it is necessary a transition from the actual structure of the fares from the second one, which includes the possibility of visualizing subscriptions, time-based fares, the discount for different user categories, and a transfer between different transport operators. The last part on which we have been working is the assessment of the infrastructure and accessibility of the different infrastructure, thanks to pathways and levels, which are files which can help end users to better visualize information on the graphical user interface. Just to give you an example, you start from a certain location, which can be the stop itself, a station, or an entrance and exit, but you have the accessibility information through the different pathway modes, which defines, for example, if you need to take a walkway, or you need to take a stairs, or the elevator, providing so information on that level. Now, we have the data, we have understood what we can do better, we need to convert them. And so I asked Marco if he has any information on how we can convert them.
I hope so. Hi all. So the converter is another part, let's say a key part of the solution we are developing in the OTP Italy project. And when you need to perform the development of a converter, you need to start with defining the mapping. So as already anticipated by Guido, you have to compare the two standards you need to convert with each other. So you take the schema of GTFS, the schema of Netex, you study them and identify the correspondence. That is what we mean with the terms mapping. Then you have to select the approach to realize the converter. And of course, you need to develop it because the converter is a software solution that performs the conversion of data according to the mapping defined and release it in an XML format. So I don't want to give too much detail on this, but basically that's the result of the analysis of the mapping. So Netex Italian profile has 5 different levels in its specification. Level 1 and level 2 are more or less already covered by GTFS, so the correspondence is good, let's say, in terms of data to be taken from one GTFS and potentially converted in Netex, level 1 or level 2. Level 3 is about fares, and of course, if the GTFS contains fares in version 2, like explained by Guido, the coverage is better. Level 4 is not covered by GTFS, but by another standard that is called GBFS. And level 5 is, let's say, covered with very basic information currently available in GTFS. For what concerns the dynamic data, the reference standard is Siri, in our case Siri Italian profile, and there is a match between Siri ET and a specific feed of GTFS real-time, and the same for other two parts of the Siri standard, VM and SX, and there are no correspondence at all for what concerns Siri FM. So this one is the conversion approach we put in place. So the approach is based on a two-step and with the usage of a conceptual reference model in the middle. So the idea is that you take the standard, for example, GTFS, and using the mapping defined in the previous step, in the previous phase, the converter map the information contained in the GTFS according to one reference conceptual model that is defined in terms of an ontology. Then the information is there, is in this knowledge graph defined according to the reference ontology. And you are ready to perform the what is called the lowering part, so the second step of the approach, where the information is extracted from the graph and mapped in terms of the target format. The implementation is based on an open source framework that is called Chimera. You can find it on GitHub. And also the reference conceptual model is available online and has been defined in the context of the Horizon 2020 project Tangent, and is based on the trans model that has been introduced by Roberto before. So let's now move on Opentripplanner, the integration between converter and Opentripplanner. So the converter of Netex, as you can see, take the GTFS, convert it to Netex, that becomes one of the data source that the routing engine of Opentripplanner can use to define the graph on which release the functionality of trip planning. Of course, when you need to manage dynamic data, the approach must be different. And in this case, the Siri converter has been developed in this way. We define 3 functional services, one for Siri ET, one for Siri VM, and one for Siri SX, that can directly assess the related GTFS real-time feed, convert the information from GTFS real-time to Siri, and offer it to Opentripplanner. But in this case, it's Opentripplanner that asks for update. So Opentripplanner can be configured to assess the functional services offered by the converter to update the graph about and obtaining the most updated information about this dynamic data. Last part, we are going to develop also a web application to visualize basically the results of Opentripplanner. In this case, both static and dynamic data will be visualized. Another important information will be the possibility to show also the degree of accessibility of physical infrastructure, and there will be also an alignment of well data to the urban network. Next step, in the next months, we are going to release the alpha version of the converter, and then after a couple of months of test, also the beta version. We are going to work on development, test and bug fixing on Opentripplanner focusing, of course, on improving the availability to manage Netex and Siri Italian profile, and then the release in production of a graphical user interface. The project will end in October, so in the coming months we will have a lot of to do and a lot of to release. Thank you very much.